so let's take a look at this ARQ resolution within the Gatekeeper, and let's just look at the questions that the Gatekeeper asks and try to determine how it's going to be able to resolve the call. So this is based on everything that we've already been looking at in regards to the whiteboard drawings. Okay, so first of all, the Gatekeeper asks itself, when the DNIS, the cont'd number, came into me with an ARQ, an admission request from the originating gateway, as part of that DNIS, as the first part, did any of the digits, and again, they don't have to actually have a hash symbol to separate them. That's just something that we as humans realize, obviously, that's a very distinguishable, non-overlapping delineator. It's a very distinguishable character that can separate what we call a TEC prefix from the rest of the DNIS, the rest of the cont'd number. But the TEC prefix doesn't have to have that hash. There's no rule that says it does. In fact, we're going to look at a way to kind of trick the Gatekeeper into thinking that there's a TEC prefix match without the hash as part of the DNIS. Okay, but the first question the Gatekeeper asks itself is there a TEC prefix match to the DNIS, the cont'd number coming in? We're not going to look at hop-off TEC prefix for right now, but if the answer is no, let's say, no, there was not a TEC prefix match. Actually, you know what? Let's go down the yes path first. Let's look at all the ways that it's able to route the call before we get to the easy default. So let's say there was a TEC prefix match. We do have a dynamic or static registration in the Gatekeeper of a gateway registered to a TEC prefix. The answer is yes. And is the special keyword called hop-off added to that? Okay, added in the static configuration of the Gatekeeper. If the answer to that is yes, then it sends it to a LRQ, which is a location request. That's how we route to a remote Gatekeeper, or at least one way that we route to a remote Gatekeeper. Not typically the common way that we do it, but it's one way. So most often, we don't use hop-off, and the answer is going to be no, it's not a hop-off TEC prefix. And it's at this point here where the Gatekeeper strips the TEC prefix in order to look for a match to the zone prefix. Remember on the whiteboard we scratched that out. And the Gatekeeper was asking itself how to match the zone prefix. Now I should note that there is no actual digit manipulation that the Gatekeeper ever does. In fact, there's no the H225 RAS signaling goes through the Gatekeeper, but the call setup between the originating and terminating gateways do not go through the Gatekeeper. Just the RAS initial request to find out who the terminating gateway is, and also for call admission control, which we'll look at bandwidth and things like that. And also there's no RTP stream. The call is not really flowing through the Gatekeeper in any sort of an IP path packet, unless it just so happens that your router in the path of the IP packet happens to be a Gatekeeper, which ours does. But other than that, there's no rerouting of signaling or media traffic through the Gatekeeper in the way that there is with, let's say, Cube or IP-to-IP gateway, which we'll look at in another module. So the only thing that the Gatekeeper knows about is sort of the status of the call. Was it set up? Was it allowed? How much bandwidth? What kind of codec? Was it torn down? All of that. So there is no, I'll reiterate this, no digit manipulation that's able to be performed to the actual DNIS, the actual cont'd number in the Gatekeeper. So why am I emphasizing that? Well, because when I say that at this point, after the hop-off TEC prefix, it answers no. If I say that the Gatekeeper strips the TEC prefix, it doesn't literally strip it from the DNIS, from the cont'd number. In fact, that TEC prefix will arrive at the terminating gateway, but it strips it just internally in order to resolve the next bit, next set of digits against the zone prefix. So whatever was matched for the TEC prefix is just temporarily, internally stripped as we now look at the zone prefix, the remaining digits. In fact, the debug we'll look at says looking at or match TEC prefix and the remaining digits. And the remaining digits are used to say, to ask the question, is there a zone prefix match? Okay? If the answer is no, then there's a special command that we can basically say reject all prefixes if they're not known. But if that command is not set, then, and in much of the Cisco documentation, you'll actually will see this command set. That just means that they want you to define zone prefixes, which it is a good thing to do. But if that command is not set, then what we'll do as the gatekeeper, we will assume that the destination or target zone equals the zone that the call came in from, where the gateway was registered when the call came in, the source zone, which will definitely be local, so we'll answer yes. And then we'll go back and ask the question. Now, again, this would only work, target zone equals source zone, not in the whiteboard discussion we just had. We had two local zones. Okay, so the source zone, let's say CUCM is the one sourcing the call. If the destination is CME and it's in a different zone, then this is going to fail. Why? Target zone is going to, the destination is going to equal the source. So we'll say the Seattle zone was where CUCM was. Is that local? Yes. Was a tech prefix found back in question 1? Yes. Okay, so go to the yes output branch. Find the local gateway with that tech prefix in the source zone. It will not find it. It will say, hey, I found a gateway that's local and with the tech prefix, but not in the source zone. It's in a different zone. So the answer would be no, send an admission rejection. Reject the call. But let's go back and do a different iteration of this. Okay, iteration number 2. Did the tech prefix match on the DNIS on the inbound call from CUCM to CME? Let's say yes, it did, based on the configuration. Was it a hop-off type? No, it wasn't. Okay, strip the tech prefix, look at the remaining digits. Is there a zone prefix match? Yes, there is. Okay, then target zone equals, or destination equals, whatever was matched by that zone prefix, which is not going to be the same as the source. It'll be a different, in this case, AMS, Amsterdam zone will be the destination or the match zone, so that will become the destination zone. Again, the debug is going to tell us this in to read plain English. Then we'll ask the question, okay, look at your config gatekeeper and tell us, is the target zone, the destination zone, is it local or is it a remote type? If it's remote, the answer is no, it's not local. Then we send an LRQ out to the remote gatekeeper. But in our case, target zone, Amsterdam, will be local, so the answer will be yes. Then we'll go on to step 4, or question 4. Was a tech prefix found back in question 1? Well, yes, it was. Okay, so now we'll make the effort to find the local gateway that's registered, either statically or dynamically, with that tech prefix in that matched local destination zone, Amsterdam. We will find one, and we'll send the admission confirmation back to the originating gateway with the terminating gateway's IP address in the ACF message, and the call will route properly. Well, at least the gatekeeper is done with the routing of the call. Then we have to get into the destination gateway if it can properly accept the call. Is there a dial peer that can accept it inbound? Is there a something to strip off that tech prefix? Because remember, the tech prefix will still be a part of the call, still be a part of the original call-ed or DNIS number. Okay, so that's tech prefix. Tech prefix can definitely route the call to a local zone. Tech prefix plus zone prefix can definitely route the call. Let's look at what if tech prefix did not match. So this is iteration 3. Does the tech prefix match on the inbound DNIS number? No. Is there a zone prefix match? Let's say yes, there is. So the destination or target zone equals the zone that we matched with that zone prefix command. Is the target zone local? Let's answer the question, yes, it is. Was a tech prefix found back in question 1? Well, no, it wasn't. Okay, is the target address registered? This is also equal to, is the alias registered? Is the E164 alias number registered? If it is, here's another easy way to route the call. Send the admission confirmation back to the gateway that has that target E164 alias registered. Okay, so we found two ways so far. Tech prefix plus zone prefix will get us to find a local gateway in the zone with the tech prefix and route the ACF message back to the originating gateway. Okay, so that's one way. Number two, no tech prefix with a zone prefix and a locally registered number will get us to route the call with an ACF back to the originating gateway, giving the originating gateway the terminating gateway's IP address, and the call will route. This is the final iteration. Let's say the tech prefix match on a new call, inbound DNS, fails. No match. Okay, is there a zone prefix match? You're always going to need a zone prefix. So yes, we match it. The destination or target zone equals the match zone that we matched in the zone prefix. Is that matched destination zone local? Let's say yes, it is. Was a tech prefix found in step 1? No, it wasn't. Is the alias or E164 target address registered? Let's say no, it wasn't. This is where we get to the catch-all net that will route just about every call through a gatekeeper. We ask the question, is there a default tech prefix set? In other words, is one statically configured in our gatekeeper configuration? If we did set one, even if the original call did not come in with a tech prefix physically prefixed to the rest of the DNS digits that we want to call, the call lead number, we will, and again, the gateway doesn't, or gatekeeper doesn't do actual digit manipulation, but just for internal resolution, it will temporarily insert its own prefix, its own default tech prefix, whatever was set, and then, okay, so assuming that this command, default tech prefix, was set, the answer would be yes, it will then attempt to select a gateway in the target destination matched zone with the tech prefix that we just internally prefixed, and then we'll send the admission confirmation with that gateway in the target zone back to the originating gateway. Send the IP of the terminating gateway. Okay, but the tech prefix that we just kind of temporarily prepended with default tech prefix, that won't be a part of the call, and so essentially the originating gateway never needed to send any sort of a tech prefix. It didn't even have to know about a tech prefix. Now the gateways had to be registered with the gatekeeper with a tech prefix, again either dynamically or statically, but the originating gateway, whichever direction the call is coming, either from call manager to CME or from CME to call manager, neither side has to send a tech prefix as part of the call lead or DNS number. So the only other thing was, is a default tech prefix set? If the answer would have been no, then we got to the bottom of the questions. There's no possible way to route the call. So again, just to reiterate, let's say this. Go back to our demonstration. Clear off and say these are the possible ways route call via a gatekeeper okay, I should say a gatekeeper local zone. One is with the combination of tech prefix and zone prefix. That will work. Number 2 option, no tech prefix. I'm just going to call it TP for right now. No tech prefix and we do have a zone prefix, and we have an E164 alias registered. Three-way, no tech prefix, plus, or I should say, no tech prefix, comma, no E164 alias. But we do have a zone prefix and we also have a default. Okay, so a tech prefix wasn't sent in the original message, but the gatekeeper adds on the default tech prefix. Those are the three ways to definitely route a call through a gatekeeper with an ARK, mission request, through a gatekeeper local zone. It's really important that you understand this flowchart. Okay, this flowchart we're going to use side by side. I highly encourage you. In fact, if you care at all about learning Gatekeeper, general or for the CCI voice exam, I will mandate that you have this flowchart either from this slide or it's in plenty of places in the Cisco documentation. We're going to show where those documentation website specifics can be found. I kind of demand that you have this flowchart next to you when we're running the best debug probably in all of iOS, which of course would have to be a hidden debug command, which is going to be the debug gatekeeper main 10. Don't worry, we'll have plenty of time to run it. When we run that command on the actual gatekeeper, it will play side by side, hand in hand with this flowchart. It will ask the questions that this one asks and answer them. So this flowchart, if you memorize it or at least understand where it is and go over all the possible steps, kind of like playing the game of chess, go over all the possible moves enough times that it just becomes like second nature. This flowchart just makes complete sense. Even if you just have to watch the recorded portion of what I just did many times over, this flowchart will help you understand every single time what the disposition of the gatekeeper is going to be based on an ARQ. Whether it will route the call to a local zone with an ACF, or whether it will route it to a remote zone with an LRQ, or whether it will simply send an admission rejection back to the originating gateway and the call will not route.